When signal generators, in particular AWGs, are connected to a sample, parasitics can severely distort the generated signal. In the example shown here, plateaus are not flat, the sink is asymmetric, and there are those nasty overshoots. There are several ways to address these distortions. For instance, recalculate a precompensated waveform and re-upload them. In this case, this full procedure is required each time a waveform is modified or introduced. Join me now and learn how our solution works. With our real-time precompensation, filter functions are applied on each sample right before playback, considering the response of the actual preceding sequence. This convenient and flexible solution allows the user to exploit all the benefits of parameterization and sequence branching, whilst retaining the precompensation and focusing on programming only the required waveform. Our real-time precompensation comes with 4 different filters: the high-pass, bounce, and exponential compensation, as well as an FIR filter. However, the most common situations can be solved with the first 3 filters using only 2 parameters per filter. Let's have a look how to choose them with an example of a distorted rectangular signal. The most apparent problem we see here is the roll-off during the plateau. To compensate this high-pass behavior, we select the corresponding filter and open the simulator. Putting the right time constant will provide us with the 3 curves: the blue showing the output as observed at the sample, the green depicting the relative output with compensation, and the red the estimated resulting signal. We transfer the parameters to the filter, activate it, and observe the scope trace. The plateaus are now flat. Zooming into the edge of each plateau, we observe a short overshoot followed by a fast decay. We employ the exponential compensation here and select the time constant and amplitude reading from the oscilloscope trace. After transfer of the settings and activation of the filter, the overshoot is gone and the rectangular signal is almost perfect. If the impedance matching is not ideal, we notice a bounce pattern at the beginning of the rectangular signal due to the finite cable length. In our case, a 1.8 meter cable causes a bounce after 20 nanoseconds, which we remove with the bounce compensation. Judging the resulting signal, the fast rise is preserved, the transition is precise, and the plateau is flat. The entire waveform now arrives at the sample as programmed. Plateaus are flat, the Gaussian and sink symmetric, and the triangular waveform shows only linear components. For more complex responses, we provide a total of 8 exponential filters and an additional FIR filter. This additional filter allows you to compensate any response on timescales of up to 72 samples, since you can tweak all of its 71 coefficients manually. So bring us your distortion challenge, and let's discuss how Zurich Instruments can help you resolve it.